It should have been impossible. In the summer of 1944, when Allied troops clawed their way through the hedgerows of Normandy, the vital port of Cherbourg lay in ruins. German demolition teams had blown every dock, every warehouse, and every crane into twisted heaps of steel. The harbor was choked with sunken ships, its entrance blocked by wrecks and mines. American engineers walking its shattered quays found nothing usable: no power, no water, no rail connection to the front. Yet within weeks, that same port would be unloading thousands of tons of ammunition, food, and fuel each day. The question that haunted even German commanders afterward was simple: how could anyone rebuild a port while still under fire? The Allied invasion of Europe depended not only on soldiers and tanks, but on something less glamorous: logistics. Every rifle round, every drop of fuel had to cross the English Channel. The plan, drafted under the code name Operation Neptune, called for seizing major ports to sustain the growing army. But German defenses anticipated that. Hitler's engineers had turned France's harbors into death traps. When U.S. forces reached Cherbourg in late June, they found its defenses as formidable as the Atlantic Wall itself. Concrete casements and scuttled vessels sealed off the harbor. To the German command, the destruction was complete enough to delay the Allies for months. It wasn't. The engineers who faced that wreckage belonged to a branch of the U.S. Army rarely celebrated in war films: the Navy's Seabees and the Army Corps of Engineers. Many were civilian construction experts wearing uniforms for the first time. They weren't soldiers in the usual sense. Their weapons were cranes, dredgers, and welding torches. But in the chaos of Normandy, their job was as decisive as any infantry assault. Without ports, the invasion would stall. The beaches, temporary and vulnerable, couldn't handle the flow of supplies needed for a million-man army. The engineers had to do what no one had ever attempted before: rebuild a deep-water port faster than an enemy could destroy it. They began with almost nothing. German demolition charges had gutted every quay and pier. Explosive beetles had been rolled into the water to collapse the seabed. Mines hung from the breakwaters, and sniper fire still cracked from nearby hills. According to post-war records, Verify source, the engineers set up their first workshops inside bombed-out warehouses using scavenged tools. The first step wasn't rebuilding, it was clearing. Navy demolition teams, many veterans of the D-Day beaches, dove into the harbor to locate unexploded ordnance. They found hundreds. The water was thick with oil and debris, and visibility near zero. Yet day by day, they worked, guided by little more than memory and the ticking of underwater timers. As the engineers cleared space, they faced another problem: how to replace the port's wrecked docks without waiting for months of construction. That's when a solution arrived from an unlikely source: the Mulberry Project. Before D-Day, British and American planners had secretly built 2 artificial harbors made of massive floating concrete caissons, designed to form instant ports on open beaches. One had been destroyed in a storm, but the concept survived. At Cherbourg, engineers adapted the idea on the fly. They used sunken ships as breakwaters, then connected pontoon causeways to reach deep water. Using prefabricated sections, they created makeshift piers that could handle Liberty ships, the cargo workhorses of the war. These vessels, built in American yards with assembly line efficiency, carried everything from jeeps to aviation fuel. Their rapid production, known as the Henry Kaiser effect, had already changed the war at sea. Now, their cargoes were the lifeblood of Europe's liberation. Still, improvisation wasn't enough. Cherbourg's inner harbor remained blocked by wrecks so large that cranes couldn't lift them. Divers had to cut them apart underwater using thermite charges. Each detonation risked triggering nearby mines. The engineers nicknamed it Underwater Demolition Roulette. Yet they pressed on, guided by officers who understood both engineering and combat. Colonel Ernest Howard, one of the senior port reconstruction chiefs, later said that the key wasn't machinery, It was mindset. "We treated every day as if it were D-Day again," he recalled, except now the beach was made of steel. By mid-July, convoys were unloading supplies at a rate no one believed possible. The Army's records show that by July 16th, over 8,000 tons of cargo were moving through Cherbourg daily, verify figure. German prisoners captured in the region expressed disbelief when shown the activity. Some had been told the harbor was beyond use for the rest of the war. Instead, within a month, it had become the busiest port in Western Europe. And yet, for all its success, Cherbourg remained under the shadow of constant air raids and artillery fire. Rebuilding didn't end when the bombs stopped falling, it happened while they fell. The miracle of Cherbourg wasn't a single moment of heroism, but thousands of acts of persistence. Men worked waist-deep in freezing water, welding at night under blackout rules, repairing cranes with spare parts made from wrecked German equipment. They lived among ruins that smelled of oil and cordite, often sleeping beside the machinery they'd repaired. Theirs was a kind of warfare measured not in territory gained, but in tons unloaded. But beneath the triumph lay a deeper mystery. How had Allied logistics achieved this feat when even their own planners had expected failure? What systems, what foresight allowed engineers to rebuild an entire harbor faster than the enemy could comprehend? And what hidden lessons lay buried in the mud of Cherbourg? Lessons that would later shape every major port operation, from Korea to Vietnam, and even modern logistics chains supporting M60 machine gun units or door gunner deployments decades later. The answer, like the harbor itself, was built piece by piece, out of desperation, design, and a quiet kind of genius. Next comes the turning point, when the battle for the port became a battle against time itself. The clock started ticking the moment Cherbourg fell into Allied hands. General Omar Bradley's planners had estimated at least 3 months before the harbor could reopen. They had been optimistic. The Germans had left nothing to chance. Every pier had been cratered with explosives, every power line severed. Sunken block ships filled the basins like a tangle of steel skeletons. Mines floated in the tide, their detonators rusting but alive. Yet from the moment the first engineer stepped onto the ruined docks, a new kind of war began, a war against entropy itself. The urgency came from the front. By mid-July 1944, the Allied advance was accelerating faster than its supply lines could handle. The beaches of Normandy, Utah, Omaha, and the rest were reaching their breaking point. Supplies still had to be ferried in by landing craft through surf and sand, a system designed for days, not months. Trucks bogged down in dunes. Fuel drums leaked. The Red Ball Express, a hastily organized convoy network, was pushing every vehicle and driver to exhaustion. Without a functioning deep-water port, the Allied armies risked starving their own momentum. Every hour Cherbourg stayed silent meant more men fighting without enough shells, rations, or gasoline. The engineers responded with what witnesses later described as organized chaos. They divided the harbor into zones and assigned each to a specialized team: divers, crane operators, demolition experts, and salvage crews. The Navy's 81st Construction Battalion worked side by side with Army port engineers, many of them veterans of civilian docks from New York and San Francisco. They had names like Murphy, Delgado, Tanaka, and Kessler, ordinary men whose civilian skills had suddenly become a strategic weapon. They were told bluntly, "You're fighting with bulldozers." One of their first successes came from a shipyard innovation born in the United States. Before the war, the Navy had developed portable cranes that could be broken down, shipped, and reassembled in days. Now those modular cranes were brought ashore piece by piece, hauled by truck convoys under intermittent shell fire. Within a week, they were operating along makeshift quays built from prefabricated pontoons. According to engineer field logs, verify source, they could lift 30 tons each, enough to hoist tanks directly from ships to waiting transporters. It was crude, dangerous, and remarkably efficient. Then came the dredgers. The Germans had scuttled more than 70 vessels in the main channel, from trawlers to cargo ships. Removing them the traditional way, by disassembly, would have taken months. Instead, the engineers used shaped charges and floating winches to drag smaller hulls aside, opening narrow corridors just wide enough for one ship at a time. Liberty ships began creeping into the harbor, guided by signalmen waving flashlights in the dark. Each arrival felt like a victory. The first to dock, the SS Robert Rowan, unloaded ammunition under fire from German artillery still hidden in the hills. Its crew refused to stop, even when shells splashed within 50 yards. What made these operations possible wasn't just improvisation, it was preparation hidden in plain sight. Allied planners had anticipated catastrophic port destruction. Before D-Day, teams of engineers and architects had studied aerial photographs of every major French harbor, designing repair kits in advance. Precast concrete caissons, standardized pier panels, even replacement generators ready for shipment. When the call came from Cherbourg, warehouses in southern England released hundreds of tons of equipment labeled only Emergency Port Reconstruction. It was an invisible supply chain, decades ahead of its time, a model later echoed in Cold War logistics that supported everything from gun truck convoy operations to forward air bases armed with M240 machine guns. Still, even the best planning couldn't prevent exhaustion. Work went on 24 hours a day. Floodlights were forbidden, so welding arcs lit the night like artificial lightning. The men ate in shifts, slept in damp tents, and battled disease from stagnant harbor water. Every day brought new injuries, crushed hands, burns, and concussions from falling debris. The port itself seemed cursed, as if resisting rebirth. On July 8th, a massive explosion from an undetonated torpedo killed several divers and set back operations by a week. Yet by the next morning, the survivors were back in the water. What kept them going wasn't orders, but something harder to define. Engineers interviewed decades later said they felt a personal challenge, a refusal to let destruction have the final word. We weren't rebuilding a harbor, one recalled. We were proving it could be done. That quiet defiance, more than any blueprint, became the core of what later historians called the Cherbourg miracle. It wasn't luck. It was the culmination of planning, skill, and willpower under conditions that defied both physics and reason. By late July, the first convoys of trucks and tanks rolled through the port's gates. Supply trains linked Cherbourg to the front, their locomotives newly repaired by French railway workers who'd returned the moment the city was liberated. By August, tonnage throughput surpassed 12,000 tons per day, verify figure, outpacing expectations by a factor of 3. General Eisenhower's headquarters noted that the rate of advance could now be maintained without drawing from beach reserves, a turning point that made the breakout at Saint-Lô and the dash across France possible. Every bullet fired in those battles had likely passed through the hands of Cherbourg's laborers. And yet, despite their achievement, the engineers received little recognition. Newsreels showed generals and tanks, not men with wrenches and cranes. Their battle had no front line, no medals for valor, only results measured in tonnage. When German commanders later inspected Allied logistics reports after the war, they refused to believe the timelines were accurate. One Wehrmacht report labeled them physically impossible under combat conditions. It wasn't wrong to call it that, but it happened nonetheless. As the last wrecks were cleared from the channel and ships began entering the harbor freely, a new phase began, one less about rebuilding and more about transformation. The engineers who had conquered destruction now faced a subtler enemy, time. Machinery corroded in salt air. Makeshift piers buckled under strain. If Cherbourg was to remain the lifeline of Europe, it needed permanence, not improvisation. That would mean rebuilding not just a harbor, but an entire idea of wartime engineering. Next comes the test that would push Allied ingenuity beyond repair and into reinvention.
The third phase of Cherbourg's rebirth began not with construction, but with collapse. By early August 1944, the port was functional, barely. The first Liberty ships were unloading daily, but the infrastructure groaned under the weight of success.
Temporary cranes broke down under overuse. Pier decking warped from constant exposure to salt water. Flooded tunnels beneath the city still hid unexploded ordnance. Even as the front lines moved east toward Paris, the port remained under periodic air threat. German artillery occasionally lobbed shells from positions miles away, forcing workers to take cover between shifts. The miracle of reconstruction had been achieved, but sustaining it required something even harder, turning an improvised system into a lasting network. Colonel Howard and his team faced a dilemma. The Army needed tonnage, not beauty, but efficiency demanded stability. Makeshift quays built from pontoons and wreckage could not endure the traffic expected in the coming months. The plan was ambitious. Replace every temporary structure with permanent installations, while never stopping operations for a single day. The harbor, in other words, had to rebuild itself while functioning at full speed. We had to keep the patient alive while operating on it, one engineer wrote in his diary. Verify source. This phase brought together an extraordinary mix of talent. Civil engineers from the U.S. Army Corps, British port designers, and local French dock workers collaborated around the clock. They drew from the same logistical genius that had produced the Mulberry harbors, but scaled it to an existing urban port. One innovation was the use of modular caisson docks. Precast concrete sections floated into position and sunk with precision, guided by divers and surveyors using instruments designed for dam construction. It was civil engineering under fire, the kind of work later echoed in massive Cold War projects that supported naval logistics and forward operating bases from Korea to Vietnam. The underlying principle, rapid, modular construction under pressure, became a foundation of modern military engineering. Meanwhile, supply throughput kept rising. By September, Cherbourg handled more than 20,000 tons daily. Verify figure. The numbers sound abstract until translated into human terms. Enough fuel for 30,000 vehicles, enough rations for 500,000 men, and enough ammunition to sustain the relentless push through France. Every shell fired by a Sherman tank, or every belt loaded into an M60 machine gun during those weeks, owed its journey to the engineers who had transformed ruin into a conduit of war. Yet the deeper success of Cherbourg wasn't measured only in cargo. It lay in the invisible systems, the repair workshops, the floating dry docks, the maintenance depots that sprouted along the quays. Here, engineers began to standardize what had once been improvisation. Equipment was coded, tracked, and replaced with mathematical precision. By analyzing every delay, they learned to anticipate breakdowns before they occurred. These methods, first applied to cranes and winches, would later evolve into the field known as predictive maintenance, still used in modern logistics. The war had forced innovation, not through invention, but through necessity. The human element, however, remained raw. Letters from the port crews speak of exhaustion and monotony, of working 14-hour shifts without rest, of the constant stench of oil and rot. Some men compared it to fighting in slow motion, a battle not of weapons, but of will. You never heard glory here, one welder wrote, only the clang of metal and the splash of harbor water. They worked beside French civilians who had lived through the occupation, often silent, watching as Allied machinery consumed the same docks once used by the German Navy. The collaboration was uneasy but inevitable. Necessity overrode resentment. When German prisoners of war were later brought in to help clear debris, the irony was unmistakable. Men who had destroyed the port were now rebuilding it under the command of those they once fought. Cherbourg became a study in contrasts. On the surface, it was industrial order, trucks, cranes, convoys. Beneath, it was a mosaic of human improvisation.
When fuel lines clogged, engineers used steam from kitchen boilers to flush them. When steel girders were missing, they cut frames from wrecked ships. Each workaround became a precedent, logged in after-action reports that would later guide operations across Europe. Those same methods shaped port construction in Antwerp and Le Havre, and even informed the design of later military logistics ships equipped with M240 gun mounts and helicopter pads for door gunners. The thread of ingenuity stretched far beyond 1944. By autumn, Cherbourg's engineers faced their final challenge: weather. Atlantic storms battered the coast, testing every structure they'd built. Floating docks tore loose. Waves hounded the breakwaters, threatening to undo months of work. Yet the harbor endured. It wasn't perfect. Nothing improvised ever is, but it held. The supplies kept moving east, feeding the advance that would soon reach the German border. When Allied commanders toured the site in October, they found a functioning city of steel. Warehouses hummed with generators. Locomotives shunted freight along repaired rail lines. The cranes, once salvaged from wrecks, moved in precise rhythm. It was hard to believe that only 4 months earlier, the same harbor had been a wasteland. Eisenhower's staff called it a textbook in military logistics. German intelligence, reviewing aerial photos, initially assumed the images were fakes. To them, the rate of reconstruction defied engineering principles. Yet the true legacy of Cherbourg went beyond logistics. It proved that war, destructive by nature, could also be a crucible of creation. The same discipline that leveled cities had forced a new understanding of how to build them back. The principles of modularity, redundancy, and adaptability forged there would influence post-war reconstruction across Europe, from bombed harbors to industrial zones reborn in peacetime. Even the technology of portable docks and container handling, precursors to the modern shipping revolution, can trace conceptual roots to that shattered French port. But at the time, none of that mattered to the men on the ground. They were too busy surviving their own success. The port that once starved for resources now demanded endless maintenance. Engines needed constant repair, machinery constant grease. And the men themselves, tired, hungry, homesick, were beginning to feel the psychological toll. The battle for Cherbourg was no longer about lifting wreckage or building quays. It was about endurance. And endurance, like steel, has a breaking point. Next comes the reckoning, how the miracle of Cherbourg nearly unraveled under its own weight, and what its collapse would teach future armies about the true cost of logistical victory. By winter 1944, Cherbourg stood as both triumph and warning. The harbor that had once symbolized destruction now roared with the mechanical pulse of victory. Ships docking day and night, cranes swinging cargo, convoys streaming toward the front. But beneath the clang of steel and the rhythm of progress, cracks began to show. The engineers who had rebuilt the impossible were facing an irony they could not ignore. The faster they worked, the more fragile their achievement became. Every ton of cargo strained the patchwork foundations they had built under fire. The temporary breakwaters shifted with each storm tide. Wooden decking splintered under truck convoys. Flooded basements beneath the city continued to leak oil into the harbor. The Allies had created a miracle of speed, not endurance. By December, maintenance consumed nearly as much manpower as unloading. Engineers spent their nights reinforcing seawalls, pumping out flooded tunnels, and welding plates onto collapsing piers. The same ingenuity that had resurrected Cherbourg was now the only thing keeping it alive. War moved on. The front lines pushed deep into Belgium and Germany, and new ports opened along the liberated coast: Antwerp, Le Havre, Marseille. Compared to them, Cherbourg began to look obsolete, its value diminishing as quickly as it had once risen. Yet its story wasn't over. Historians later noted that while Antwerp became the logistical giant of late 1944, Cherbourg had been the bridge that made Antwerp possible. Without those first critical months of supply, the Allied advance might have frozen in place before reaching Paris. Eisenhower's staff quietly acknowledged that in reports, calling the operation a logistical victory of the first magnitude.
But for the engineers still working there, glory was irrelevant. They lived in mud and noise, often forgotten by the soldiers they supplied. Many never left Europe after the war. They stayed to rebuild France's civilian ports, applying lessons learned in fire. For them, Cherbourg had become something more than a battlefield. It was proof that engineering, at its core, was about resilience. They had learned that logistics was not a science of perfection, but a discipline of adaptation. Every miscalculated tide, every broken crane, every night spent welding in freezing rain had forced them to innovate in ways no textbook could predict. The official after-action reports captured it in dry military language. Improvised dock facilities exceeded planned capacity by 240%. But between those lines lay human endurance.
Divers who couldn't see their hands in front of their masks worked until their ears bled from pressure. Crane operators learned to steady their loads by instinct because wind gauges were destroyed. Electricians scavenged copper wiring from German bunkers to power floodlights. Mechanics turned scrap metal into bearings and forged replacement bolts in makeshift furnaces. These acts, unrecorded in headlines, formed the backbone of Allied logistics, the hidden war behind the war. When the guns finally fell silent in May 1945, Cherbourg was still operating. Ships carrying occupation supplies and relief cargoes continued to pass through its gates. But the men who had made it happen went home quietly. Few medals were awarded for port reconstruction. Theirs was not a story of combat, but of competence, something the public rarely celebrates. And yet, when post-war military academies studied the European campaign, Cherbourg became a case study in engineering under duress. The operation reshaped doctrines on combat engineering, port seizure, and rapid infrastructure recovery. Decades later, the same principles would appear in manuals guiding U.S. forces in Korea, Vietnam, and Iraq. Anywhere a military needed to sustain operations far from established bases. The lineage is unmistakable. The modular pontoons that once formed Cherbourg's makeshift docks evolved into the floating causeways used in Vietnam to unload gun truck convoys and M60 machine gun carriers along riverbanks. The system of rapid repair logs pioneered there influenced Cold War maintenance protocols for armored divisions and aircraft ground crews. Even modern NATO doctrines on expeditionary logistics trace their roots to those same impossible weeks in 1944. The tools changed, but the idea remained. No battle can be won without the engineers who build the road to it. There is also a moral lesson buried beneath the statistics. Cherbourg revealed the paradox of modern warfare, that the same creativity capable of mass destruction can also restore what was lost. The engineers' struggle mirrored the war itself, a contest between annihilation and renewal. They fought not with rifles, but with cranes and courage, proving that innovation could emerge from ruin. When a German officer toured the rebuilt port after surrender, he reportedly muttered, "We destroyed it to stop you, but you built faster than we could think." That single sentence captured what even the Allied command struggled to express. The forgotten miracle of Cherbourg was never truly about bricks or steel.
It was about time, how a handful of exhausted men compressed months of work into days, how they refused to accept that destruction was final. Their story stands as a reminder that victory in war is not merely a matter of tactics or firepower, but of endurance, organization, and the stubborn refusal to stop building. Today, walking along Cherbourg's waterfront, there are few traces of the 1944 ruins. The docks are modern. The cranes are automated. Tourists pass the breakwater without realizing that beneath their feet lies the welded skeleton of a wartime harbor reborn from ash. Somewhere under the cold water rest the remnants of Liberty ships that once formed makeshift piers, silent monuments to the invisible war that sustained the visible one. History often celebrates the battles that destroy,
not the hands that rebuild.
Yet in the long arc of memory, Cherbourg endures as a counterpoint, a testament to the engineers who turned catastrophe into infrastructure, chaos into order. They proved that courage isn't always loud, and that sometimes the most decisive victories happen far from gunfire, measured not in enemy losses, but in tons unloaded, miles supplied, and lives sustained. In the end, the story of Cherbourg teaches us something universal about human invention. Every technology, every system, whether a bridge, a weapon, or a port, is a reflection of the people who create it. And when destruction comes, as it always does in war, it is the builders, not the breakers, who decide what endures. The cranes may be silent now, but their lesson remains, that the true miracle of Cherbourg was never the harbor itself, but the human determination to make the impossible possible again.